Today in Capechi's Corner, we are going to look at solving absolute value inequalities. Now, similar to solving absolute value equations, we know that we may often have more than one solution. So when we're dealing with inequalities, if we have a greater or greater than or equal to, we know that connection is going to be an or in this compound. Sounds like greater, that's how we remember. If I have less than or equal to, that compound inequality is connected with an and. It sounds like less than to help us remember. Okay, so let's look at example 1. We have less than, that's less and, right? So we know we're going to use an and in between. So similar to our absolute value equations, here's my wall. Once my absolute value is isolated, which it is, then I can split it. I'm going to rewrite it the first time exactly as is without the absolute value symbol. Put the and in between. And then this time I'm going to have two changes. Whatever is in the absolute value symbol stays the same. I'm going to change the direction of that sign, and that positive 3 is going to become negative 3. Now I'm simply going to solve, and then I'll put it all together. So I have m is less than negative 2, and I have m is greater than negative 8. Okay, so I know I have an and, so I know I'm going to have a compound inequality with the and as connecting. I'm going to put my m in the center. Between negative 8 and negative 2 on the number line, negative 8 is to the left, and negative 2 would be to the right. My relationship between m and negative 2 is pointing to the m, and the relationship between m and negative 8 is pointing to the negative 8. Both inequality symbols are pointing to the left, so I'm all set. And here's what our inequality would look like. Open circle, right, because we do not have a line underneath, and then the barbell in between. So we're including all numbers between negative 8 and negative 2, but not those numbers themselves. And looking at our next problem, we have less than or equal to. So that's an and, less than. Before I can split it, I have to isolate my absolute value. So I'm going to add 2 to both sides. I have 3 times the absolute value of 2x plus 5. Less than or equal to 9. I'm going to divide both sides by 3. And I have the absolute value of 2x plus 5 is less than or equal to 3. Okay, now I can split it because I have the absolute value is the only thing I have on the left-hand side. So I have 2x plus 5 is less than or equal to 3. I'm going to write the word and in between so I don't forget. My second inequality, 2x plus 5, again, change the direction of that sign, and that 3 becomes a negative 3. Okay, now I'm going to solve. So I'm going to bring the negative 5 to the other side, and I have 2x is less than or equal to negative 2. Divide both sides by 2, and x is less than or equal to negative 1. Then on the right-hand side, again, I'm going to use the and. I'm going to bring this 5 to the other side, and I have 2x is greater than or equal to negative 8. Divide both sides by 2, so I have x is greater than or equal to negative 4. Okay, so before I graph, I'm going to rewrite it. I'm going to put my x in the center. My negative 4 would be to the left of negative 1, so I'm going to set those up. Looking at this, x and negative 1, I'm pointing to x, and x and negative 4, I'm pointing to the negative 4. So that's my final inequality there. Okay, this time because I have that equal sign underneath, I'm going to have a closed circle above negative 4, and I'm going to have a closed circle above negative 1, and I'm going to have a barbell in between. Okay, moving on. This time, this is greater, right? So I know I'm going to have an or. Again, my absolute value is already isolated, so I can split it right away. Right? I have, and then I have 4m minus 20. I'm going to change the direction of the sign, and that makes that negative 12. Now, notice also with all the absolute value, it's either always going to be greater than or equal to and less than or equal to, or with an or there. So I'm either going to have both when I go to graph it. Both numbers above the numbers either going to be both closed circle or both open circle. It will never be one of each. Okay, here's my wall. Again, let's get my variable by itself. So I have 4m is greater than or equal to 32. Divide both sides by 4. and m is greater than or equal to 8. Write that word or between, right, as a reminder. I'm going to add 20 to both sides. And I have 4m is less than or equal to 8. Divide both sides by 4. And m is less than or equal to 2. So that is my compound inequality. And now I'm going to graph it. So I have m is greater than or equal to 8. So that's a closed circle. And those values are to the right. Or m is less than or equal to 2. So again, closed circle above 2. And that arrow goes to the left. All right, let's take another look at a different problem. Again, there's my wall. And again, this is greater or equal to, so this is going to be another or. I'm going to isolate my absolute value by adding 2 to both sides. I have greater than or equal to 12. Divide both sides by 4. And I have the absolute value of m plus 1 is greater than or equal to 3. Now that I've isolated that absolute value, I can split it. So I have m plus 1 is greater than or equal to 3, or m plus 1, remember I'm going to change the direction of the sign, and that positive 3 becomes a negative 3. Now I'll solve. So I have m is greater than or equal to 2, or I have m is less than or equal to negative 4. So that's my final answer right there. Now I just have to graph it. So I have m is greater than or equal to 2, so I have a closed circle to the right, or m is less than or equal to negative 4, so a closed circle above negative 4 to the left. All right, let's take a look at our last problem. Word problem using absolute value inequality. Members of the debate team are traveling to a tournament where they will stay in a hotel for 3 nights. That's going to be important. The total cost for each member must be within $20. So that's going to be a little bit of our range there of $175. Which of the hotels shown can they consider? So over here we have 3 options. Each have different prices. So let's see which ones are the options. So we have our absolute value. We know it's going to be less than or equal to, and our range is that $20 right there. So that's going to go on the outside. Okay, we know we're going to have that minus 175. Now, normally this right there would be our variable, but we're talking about 3 nights, not just the price of 1 night. So that instead of x is going to have to be 3x. Okay, and then we're all set. Now, I do have my absolute value isolated on one side, right? So I can split it. And we know this is an and, right? We know it's going to be an and between 2 numbers like a barbell. So that's how I knew it had to be less than or equal to, because I was also able to include that $20. So I have 3x minus 175 is less than or equal to 20. And 3x minus 175 is greater than or equal to negative 20. So I'm going to isolate, and I'm going to get that x by itself. 3x is less than or equal to 195. Divide both sides by 3. And I end up with x is less than or equal to 65. I need that and in there. Do the same thing with my other inequality. And I have 3x is greater than or equal to 155. Now divide both sides by 3. Now this doesn't go evenly, but I'm talking about money, so I know I can go 2 digits after the decimal place. So that becomes 51.67. I'll round it to that. Okay, so I need a compound inequality. So that's going to go to the left. And so I know I need between $51.67 and $65. So back to my hotels. Which hotels fall between those 2 price ranges? And it's going to be Hotel B and Hotel C. They're the hotels that can be considered. Okay, thanks so much for stopping by today. You have a great day.